guys, Mr. Klein here. We're talking about Chapter 9, Lesson 2, Volcanoes. An explosive topic, if you will. Let's go ahead and let's get started. By the end of this lesson, you will be able to answer these three questions. Number one, how do volcanoes form? Number two, how are they classified? And number three, what factors contribute to the eruption style of a volcano? So let's go ahead and let's get started. Let's actually identify what exactly a volcano is. Now, a volcano is a vent in the Earth's crust through which molten rock flows. Okay, if you remember, molten rock below the Earth's surface is what we call magma. Okay, once it hits the ground, hits the Earth's surface, it then becomes known as lava. So remember, magma below surface, lava on top of it. The vent in which the magma comes out of Earth's surface is a volcano. Now, how do volcanoes form? Well, volcanoes normally form along convergent plate boundaries when one plate subducts another one. Okay, these subduction zones are usually between an oceanic plate and a continental plate. What happens is magma from the hot mantle rises through cracks in the Earth's crust and forms a volcano. And molten rocks that erupts onto Earth's surface is what we call lava, like I just said. Now, sometimes at divergent plate boundaries, magma rises in cracks between the two plates, forming volcanoes. You'll see that a lot of times at mid-ocean ridges and in Africa's Great Rift Valley. So if you remember this video, you can see what happens at a convergent plate boundary. Okay, plates move towards one another at convergent boundary. Here is this is a part of a continental plate. Okay, this is an oceanic plate. And when we put it in motion, it goes down into the Earth's surface and it melts. And as it melts, pieces of the mantle push up and form earthquakes. Form volcanoes. Okay, and of course, earthquakes will take place at plate boundaries, especially convergent boundaries areas like this. And as whenever we looked at with earthquakes and volcanoes usually occur in the same places. Okay, so all these volcanoes right here are a result of magma pushing up to the surface at this plate boundary. However, it's not the only place where that happens. Like we said, at divergent plate boundaries, what you'll have is volcanic eruptions right here along the mid-ocean ridge. And what happens over time is this magma comes up to the surface and it forms a mid-ocean ridge as it spreads. Okay, and this, of course, all takes place throughout the place of plate tectonics. So we see over time, volcanoes form, magma comes up, mid-ocean ridges, things of that nature. Now, volcanoes that are not associated with plate boundaries are what we call hotspots. Geologists theorize that hotspots form over plumes, which are places where hot magma rises due to convection currents in the mantle. Okay, a big example of that is Hawaii. And if we go ahead and we zoom out from class and we get going, we'll see how Hawaii is an example of this. Okay, and if you look right here, throughout Hawaii, if you see this very long string underneath the Pacific Ocean, scientists theorize that this is actually the movement of the Pacific plate over time, and this has all been over the hot zone. If we go back and we look at Hawaii, okay, what we see is these series of islands. Okay, they change in size, and some of them are little tiny specks. Okay, and they continue for hundreds of miles all throughout the planet. Okay, throughout the Pacific Ocean. And so scientists theorize that there's a hotspot of a convection current right here. And over time, as plate tectonics will slide the Pacific plate over, another island will form. So that's where volcanoes occur, where there aren't plate boundaries going on. But we're going to be talking about where do volcanoes form. Most of them occur on or along plate boundaries. And the area where we see the most volcanic activity is what we call the Ring of Fire, the area of earthquake and volcanic activity that surrounds the Pacific Ocean. Okay, and in terms of the United States, almost all volcanoes occur near the Pacific coast. Now, if you don't believe me, let's look at this map. Okay, so if I have this map open and I turn on all the volcanoes of the world, and I turn the globe, and every single one of these is a red spot, is a volcano. Let's look at Earth. Okay, we travel along the Pacific plate. and we go down into South America, we see volcanoes all over the place. Even in Antarctica, we go across Antarctica and you see volcanoes. And we go through New Zealand, volcanoes. Along this plate boundary, we see volcanoes. Volcanoes, volcanoes, volcanoes. Go through Papua New Guinea, into Indonesia, okay, even and into the Philippines, and we swing up. We swing to the north, and what do we see? We see more volcanoes, and we even see volcanoes here along this ridge line. This is the Philippine plate right here, into Japan, throughout Russia, across Alaska, throughout Canada, and into the western United States. That's the Ring of Fire. And if we line it up with earthquakes over if we put up historic earths, there we go. If we put up earthquakes over time, what do we notice? But the earthquakes coincide with the volcanoes. Okay, as my computer chugs to a halt as it gets all the earthquake information. If you notice, look at all those earthquakes and where do they coincide? They coincide with the volcanoes. So scientists have theorized that volcanic activity and earthquake activity is oftentimes the same, one and the same. So let's look at the types of volcanoes. There are three major types of volcanoes. A caldera is a fourth type. It's a collapsed large volcanic basin, but we're not really going to talk about that too much. Okay, the first one is what we call a cinder cone. Cinder cones are small, steep-sided volcanoes that erupt gas-rich basaltic lavas, usually not terribly violent. This is the Capulin volcano in New Mexico. It's actually an extinct volcano. Over time, it moved away from the hotspot, and there's no more volcanic activity over there, so it is extinct. Okay, you notice it looks like a nice cone. That's what we think of when we think of a volcano. The second type, the other type that we're pretty aware of, is what we call a composite volcano. They're large, steep-sided volcanoes that result from explosive eruptions repeatedly of andesitic and rhyolitic lava along convergent plate boundaries. Essentially, composite volcanoes or the big volcanoes that usually explode. There's a Tavaruvaror volcano in Papua New Guinea. It usually erupts in violent explosions like with Mount St. Helens, which was a stratovolcano, which we'll look at in a minute. The third type is a shield volcano. Oftentimes we'll see these at hotspots. They're large, gently sloped volcanoes that result from quiet eruptions of basaltic lavas along divergent plate boundaries and oceanic hotspots. You oftentimes see shield volcanoes at mid-ocean ridges. Okay? Now, usually what will happen with a shield volcano is you have a slow eruption that creates a lava flow. And lava flows are just that. It's a flow of lava. It goes really slowly and rarely are deadly. You can actually run away from one. They can last for many months or longer. And here's an example of a shield volcano, Mauna Kea, on the island of Hawaii, the Big Island. Okay, so that's a shield volcano. So remember, cinder cone volcanoes, that's that classic shape of a volcano where we think of it, and that's the magma chamber where it comes out of. Then stratovolcanoes are where you have large explosions and eruptions, lava flows down and forms essentially sedimentary layers, if you will, of lava, and they usually have large explosions. And finally, shield volcanoes have large lava flows that are gentle and they're very rich with basalt and things like that. Now, what can happen when a volcano erupts is you can have what's called volcanic ash, which we'll get to in a minute, and explode up to 40 kilometers into the air. For example, when Mount St. Helens exploded, this big cloud right here is the actual ash coming out of Mount St. Helens after the explosion. So it could go up pretty high. Now, what can also form are mud flows when thermal energy from a erupting volcano melts snow. Lots of times, especially high volcanoes will have large glaciers and things like that. So the heat of the volcano melts the water, turns into a flash flood, which mixes with mud as well as the ash coming up from the volcano, and it flows downhill. Okay, and this oftentimes can happen really quick. So what we're going to do is we're going to watch a video. It's 18 seconds, no sound, anything like that. And it's kind of sped up of what happened when Mount St. Helens erupted in 1980. So if we watch it, we see what happens. Okay, that's the mud flow coming down. Okay, you see the mountain literally melting away almost, and then the volcanic ash comes out of the cloud, it comes out of the volcano. Okay, and it comes spiraling down, and the volcano continued to erupt, and that's what you saw in that satellite image. So, see, that's that image once again. Now, a pyroclastic flow is a fast-moving avalanche of hot gas, ash, and volcanic rock. Especially when you have big volcanic eruptions, major ones, which we'll look at at the end of this lesson, you'll have that fast-moving avalanche of hot gas, ash, and volcanic rock that pretty much kills everything in its path. Now, you might be concerned about volcanoes. I mean, well, what happens if a volcano goes off? Are everyone doomed? I mean, don't people live by volcanoes? Didn't you show us that Mount Fuji is kind of like by Tokyo, where like a lot of people live? Well, here's the thing. Kind of like earthquakes, volcanic eruptions can be predicted by studying changes in the ground and patterns of earthquakes. Okay, because what we do is we look at the earthquakes and stuff, and we find that the more earthquakes there are, the chances are that there's a volcano that's about to erupt. So, let's go ahead and let's look at some of these. Here is Capulin Mountain. It's an extinct cinder cone. You can see what a cinder cone volcano looks like in New Mexico. Okay, you see it's that nice round shape. Okay, and this is looking out into the surrounding countryside. And you can actually see here's that shape. See, it's a nice, it's what we could think of a volcano. And there are other volcanoes to look at. Um, if we were to go, let's go over to Europe, where we wouldn't think a volcano would be, in Mount Vesuvius. If you remember from world history and the Roman Empire, Mount Vesuvius exploded, and the pyroclastic flow flooded Pompeii and killed a surrounding population. Okay, Mount Vesuvius is still, every once in a while, we'll show some signs of volcanic activity, but it's not the most active volcanoes in there. In fact, the most common one which we see volcanic activity happens is actually here in Sicily, which is the island below Italy, and that's Mount Etna. Every once in a while, you'll hear on the news pop up that Mount Etna has, erupted and things like that. And this is where they're talking about. Hey, lots of volcanic ash, a little bit of snow, but this volcanic ash has fallen as a result of the repeated eruptions. Okay, so let's go ahead and let's go look at Mount St. Helens. Okay, let's fly back across. And this is the volcano I was telling you about. It erupted in 1980. Okay, and it's now kind of closed off. It still shows signs of volcanic activity. Okay, and up to the north is Mount Rainier, which is another dormant volcano. Okay, this is the side that blew up. Okay, so now there's this big, huge hole in the mountain where there was before. And so that's this area right here. Okay, and all this is all the flow, the explosion and the eruption, and it headed out, and this is all ash and stuff going from the eruption. So volcanic eruptions are a pretty big thing, especially if a mountain decides to go up. Speaking of mountains that decided to go up, in 1992, a volcano that pretty much no one was thinking about was Mount Pinatubo, and we'll talk about it in a minute in terms of climate change. But Mount Pinatubo went up and had a major volcanic eruption and spread of ash and things like that all in the area and caused a collapse, and now there's a lake that's formed in there. But Pinatubo is important in that it showed us what climate change can happen with a volcanic eruption. You see, that's the actual lake, and that's the walls of Pinatubo. Pinatubo, Etna, Mount St. Helens, those like that, those are all stratovolcanoes. And Capulin Mountain was a cinder cone, and if we go look at Mauna Loa in Hawaii, that's of course a shield volcano. And this whole area, this nice slow volcanic eruptions. In fact, Mauna Loa is one of the most active volcanoes on Earth. Okay, and see, this is the kind of lava that will drop. Okay, really drippy, really liquidy, things like that. Okay, so this is the result of a volcanic eruption. Okay, so let's go ahead and let's keep on going in this lesson. Okay, volcanic eruptions, of course, we have volcanic ash, tiny particles of pulverized volcanic rock and glass that erupts explosively. Okay, glass being essentially superheated sand cooling off. The eruption style of volcano depends on the amount of gases dissolved in the magma, especially the amount of dissolved water vapor. The more water vapor there is in there, the more explosive the volcanic eruption will be. So, Mauna Kea and Mauna Loa, okay, not really explosive eruptions, not a lot of water vapor. Okay, Tavavur volcano, lots of water vapor. Okay, Mount St. Helens, definitely a lot of water vapor. Okay, now in talking about magma and lava, we need to talk about a term where we talk about fluids, which is viscosity. Viscosity is a fluid's resistance to flow. Okay, if you think about it this way, if you've ever had syrup, okay, and you had pancakes and you want to put syrup on your pancakes, you keep the syrup in the refrigerator, it doesn't really flow. Why? Because it has a very high viscosity. Okay? Whenever it does want to, however you throw it in the microwave 10-15 seconds, it suddenly flows real easy. That's when it has a low viscosity. Viscosity of lava is higher. Okay, it becomes stickier and doesn't flow as much when lava has a high silica content. Okay, if it has a lot of silica in it, it'll flow real slowly. If it doesn't have it, it'll flow real easy. Now, as magma, this is what happens when an eruption takes place. As magma rises towards the Earth's surface, the pressure on it decreases, okay, because there's less of the Earth pushing down on it. Bubbles of gas form and rise in the magma. The bubbles affect the explosiveness of lava and the type of rock that forms as lava cools. Essentially, what will happen is if rock doesn't hold down the uh, rock doesn't have is if it's pretty solid and won't let the gas escape, the more pressure will build up, the more explosion it is that the volcano will have rather. However, on the other hand, if there's a lot of igneous rock sitting on top of it that has a lot of bubbles and things like that, it's extrusive, a lot of extrusive igneous rock on top, it'll allow gaps in order for the gas to escape, which will allow the explosion to not be as great or not even have an explosion at all, and the lava just bubbles up and flows out. Okay, now the release of large amounts of volcanic ash can affect Earth's climate by blocking sunlight. Now, what happens when drops of sulfuric acid and volcanoes form in the atmosphere? What happens is they reflect sunlight into space. So the ash, the sulfuric acid, pretty much puts a block on the sun. And volcanic ash and acid droplets in the atmosphere will cool the Earth's climate. And whenever we talked about the extinction of the dinosaurs, that's what we talked about, that the meteor that hit, okay, the Chicxulub crater threw up so much dust in the earth that it actually cooled down the earth. And so we were able to see this in action when Mount Pinatubo erupted. At the Mauna Loa Observatory, we were looking at the amount of light reaching the surface of there. Okay, right here was a volcanic eruption. Okay, in the early 1960s, slight drop in the sun. Okay, El Chicon, which was a volcanic eruption in Mexico, dropped it by over 10%, okay, but it came right back up. Then Mount Pinatubo erupted in 1992. It dropped it some more, but the eruption was so big that the amount of sunlight reaching Mauna Loa didn't go for several years. And in this area, Earth's temperature, average temperature, dropped by a degree of Celsius. Okay, so Earth's temperatures dropped by 1 degree. Now, if you were to have, according to what scientists think of at the Permian extinction event, several large volcanic eruptions, that would drop Earth's temperature a lot over time. The Chicxulub crater, okay, a large meteor impact causing widespread widespread debris being thrown in the atmosphere would drop the solar radiation reaching the Earth by more than just 10, it might 20, 30, 40%, and it would drop Earth's temperature over time, which would cause lots of changes. So let's go ahead and wrap up this lesson. By the end of this lesson, you'd been able to answer the following questions. How do volcanoes form? Well, a volcano forms when magma erupts onto Earth's surface, either along plate boundaries or over a hotspot. Now, how are volcanoes classified? Well, they're classified according to their shape and size. Cinder cones have nice, smooth sides, usually not really tall. Stratovolcanoes form as a result of repeated eruptions. They create essentially sediment layers of lava, and they tend to be very tall. your tallest volcanoes on Earth tend to be stratovolcanoes. Finally, you have shield volcanoes, which have very slow, bubbly eruptions that have lava flows, and they're nice and they're broad. Finally, what factors contribute to the eruption style of a volcano? Well, the minerals and gases in the magma contribute to that, especially two things. One, the amount of silica, which makes the volcano lava very viscous, which means it won't move, which means it's more likely to get thrown up into the air. And finally, the water vapor. If there's a lot of water vapor in there, it's more likely that the volcano will explode violently rather than smoothly. So that's your lesson on volcanoes. Always, if you have any questions, feel free to let you know. Thanks for watching.